everyone, welcome to Samadhan Life Science. Today I will talk about thermodynamics. So in simple terms, thermodynamics is the study of energy changes in any process, be it chemical or physical. And to understand, we have to consider a few basic functions. Those can be of two types. First, state functions. Those depend only on the initial or final state of the system, not on how the process went or the path the system have taken to reach the final state. For example, volume, pressure, temperature, and here are two more: internal energy and enthalpy. And the other functions are path functions. Those depends on the process of the path they have taken between the states. That is, the history of the process or the path is matters here. So for example, work or heat. So now let's discuss them one by one. So first, internal energy, which is the total amount of energy in a system, and it can be sum of different kinds of energy. For example, potential energy of the system or the molecule, if we are considering the molecule as a system, and the energy of chemical bonds, etc. And here internal energy I will represent as U equal to the amount of heat added to the system Q plus amount of work done on the system W. For example, if a system absorbs 100 joule of heat and does 40 joule of work on the surrounding, then we can calculate change in internal energy is equal to 100 joule heat absorbed plus minus 40. Why minus? Because the system is doing the work on the surrounding. I will come to the sign later also. So here the answer is 60 joule. The next function is heat. This we already know as the energy transfer between system and surrounding if there is a temperature difference. Now what's the system and surrounding? System is the part of the universe you are studying. So it's contained by a boundary. So it can be a beaker if we are considering a reaction, or a room, anything like that. So and the rest of the universe that is outside the boundary is our surrounding. So if the system absorb heat from surrounding, then Q is greater than 0, positive. For example, melting of ice. And if the system release heat to the surrounding, then Q is negative, less than 0. For example, combustion. Now let's go to the next function, which is work. This is energy transfer, but not in form of heat. So if I put force or apply force to an object and some displacement is there, then this is our work. So displacement into the force. And here I will represent work as minus PdV if the external pressure P is constant. Here also the sign matters. So if the system is doing the work on the surrounding, then W is negative, less than 0. For example, expansion of a gas. And if the system is doing the if the surrounding is doing the work, for example, compression of a gas, then W is greater than 0 or positive. So let's take an example here. During an isothermal expansion of an ideal gas, the volume increases to 1 to 3 liter. If the external pressure is 1 atmospheric, then we have to calculate the work. So here minus 1, final volume minus initial volume, so minus 2 liter into atmosphere, or we can convert it into joule by multiplying it by 101.3 joule. So the answer is 6 joule, right? So let's take the last function for today, which is enthalpy. This is the total heat content of an object or the system. So enthalpy is sum of internal energy and work done. And so the change in enthalpy delta H is equal to delta U plus P delta V. So this enthalpy change is enthalpy of product minus enthalpy of reactant, and we can express this enthalpy in different name. For example, if we are considering a chemical reaction, then the enthalpy change will be heat of reaction, or if we are considering formation of a specific product in a reaction, then we can consider the enthalpy as heat of formation. Similarly, in this question, which among these four ions has highest enthalpy of hydration. So this is the heat released when a gaseous ion gets surrounded by water molecules and get dissolved in aqueous solution. So the enthalpy changes enthalpy of hydration. And here two factors are important. Those are the charge on the ion and the size of the ion. So if we have higher charge and smaller size, that is smaller ionic radius, then the charge density of the ion is higher and water can get close to the ion more easily and exert electrostatic force. So if the charge is higher and size is smaller, then enthalpy of hydration will be higher. Higher in the sense that more negative. The value will be higher, but the value will be negative because product minus reactant. So product is more stabilized. So here between these four ions, the charge is same here for all of them, that is plus 2, but titanium 2 plus has the smallest size among them, so this has highest enthalpy of hydration. Now the last example for today, that is which of the following is or are correct when two single complementary strands of DNA come together to form a double helix at a given temperature. So here in the option we have enthalpy change and delta S, that is entropy change. So let's first consider enthalpy. So here two single strands are coming together to form a duplex by hydrogen bonding and stacking. So the duplex is more stabilized by hydrogen bonding and stacking. So the product minus reactant delta H is less than 0 because product is more stabilized. And for the delta S, entropy is the degree of randomness or degree of disorderness in a system. So if two single strands are coming together to form a duplex, then the degree of randomness is decreasing. So the so the double helix is more order. So here delta S is also 0. So in the next video, I will talk more about this delta S and delta H and the favorable processes. So I hope you enjoyed today. Thank you for watching today. See you in the next video. Bye bye.